Hello children, welcome to GNANA DEEKSHA concept-based digital learning. I am Leelavathi, PGT Mathematics, working at TSWREIS Girls, Nasili, HRR West. Today's our topic is congruent and similar triangles. Before we start the actual definition of congruent triangles and similar triangles, let us see what is congruency in nature. In general, how do we identify the congruent objects? Children, you might have observed your mother or grandmother drawing rangoli in front of your house. Beautiful rangolis you can see in front of house. So these rangolis consist of different shapes. If you see this rangoli, here you have same shapes. Let me highlight this. This and this are same in shape, and their sizes are also equal. So the objects which have same shape and size. The objects which have same shape and size are called congruent objects. The objects which have same shape and size. And not only rangoli, when you open your textbook, see the pages of the textbook. When you open the two pages of the textbooks have the same shape and size. And when you close them, when you place one paper on the other, they superimpose. They are superimposed. This kind of objects, when they place on one on the other, when they superimpose, are said to be simply congruent to each other. And look at this beautiful butterflies. These butterflies, wings, when you observe the wings of the butterflies, they are congruent to each other. So these beautiful butterflies, when they fly, how do we feel? We feel very happy. So beauty leads to happiness. So due to that happiness, what do we get? We will become very healthy, very good health. And this health improves our immunity. So this immunity, in this pandemic period, all of us are very much in need of this immunity. So children, I request you all to focus on this topic and learn so that you can enjoy the beauty and feel happy and become healthy and also simultaneously improve your immunity power. Now, in terms of the language of mathematics, how do we define congruency? We will see. This is related to shapes, and in geometry, the shape starts with a point. You all know point is a undefined term. It has no definition at all. We can name it. This point is named as A. And let me take one more point, B. When I join these 2 points, and it is forming a line segment. Let us consider this line segment is of length 4 centimeters. And take 2 more points, C and D, and also consider it as 4 centimeters. So we have 2 line segments, AB and CD, of length 4 centimeters. If you observe here, these 2 line segments have the same length. Therefore, these 2 line segments are congruent to each other. And the symbol of congruency is this, and we read it as E is congruent to. So here, the line segment AB is congruent to CD. When we place this line segment CD on AB, what happens? This point C coincides with A, point D coincides with B. These 2 are of same shape. They are line segments, as well as their lengths are equal. Means they are of same size. As both the conditions are satisfied, AB and CD are congruent to each other. Suppose if we have one more line segment, EF, of length 5 centimeters. Okay, 5 centimeters length. EF of length 5 centimeters. When you compare these 2 line segments, AB or EF, CD or EF, they are of different lengths. Means they are not congruent. They are of same shape but of different size. So CD is not congruent to EF. Line segment CD is not congruent to EF. So this is how we define the congruency of line segment. 2 line segments are said to be congruent when they are of same length. Now let us see when 2 angles are congruent. Congruency of angles. So here I have 2 angles, ABC and EFED or DEF. Two angles. These two angles are of measure 60 degrees each. So these two angles have equal measure, right? 60 degrees and 60 degrees. Therefore, we say angle ABC is congruent to angle DEF. These two angles are congruent to each other as their measures are same. Now let us consider one more angle. Can you guess what kind of angle is this? What is the measure? Is angle 90 degrees XYZ. Let me name it as XYZ. So angle XYZ is of 90 degrees. So 60 degrees and 90 degrees. Their measurements are different. Therefore, we say angle ABC is not congruent to angle XYZ. So we are discussing line segments and angles congruency as we use these two in the definition of congruent triangle. I hope you understood congruency of angles. Two angles are said to be congruent only when their measures are equal. Okay? Congruent circles. Let us see when two circles are congruent. Two circles are said to be congruent when the radii are equal. Let us take a circle with center O and radius 3 centimeters. And one more circle with center O dash and 3 centimeters radius. These two circles have same radius 3 centimeters and 3 centimeters. Therefore, we can say these two circles are congruent to each other. So, two circles are said to be congruent only when they have same radius. And we have n number of examples from our day-to-day life. The bangles of same size are congruent to each other. We have different sizes of bangles now, 2.2, 2.4, 2.6, different sizes. So those same size bangles are congruent to each other. And if you observe the symbol of Olympics, that also consists of congruent circles. So these are some examples from day-to-day. So two triangles are said to be congruent. Let us consider two triangles first. Triangle ABC and one more triangle DEF. Okay? These two triangles are said to be congruent when all the 6 elements of first triangle are congruent to corresponding 6 elements of next triangle, second triangle. Here you have to focus more on corresponding. What is the meaning of corresponding? Let me explain. Look at my hands, palms. So here when I place one on the other, thumb is placed on thumb, index finger, middle finger, ring finger and little finger. So the part which is placed on the other are called corresponding. So similarly, in the same way, when we lift this triangle ABC and place it on DEF, automatically this AB falls on D and angle A falls on angle B. Angle B falls on angle E. Angle C will be coinciding with angle F. So they fall on these 3 vertices or angles. Even sides AB falls on DE, AC on DF and DC and EF fall on each other. So these parts are called corresponding parts. And you all know there are 6 parts in a triangle, 6 elements, 3 angles and 3 sides put together, 6 elements are there. So if these 3 angles and 3 sides of triangle ABC are congruent to corresponding angles and sides of triangle DEF, then we say triangle ABC is congruent to triangle DEF. So what is the rule? Angle A is congruent to angle B. Angle B is congruent to angle E. Angle C is congruent to angle F. And coming to sides, AB is congruent to DE, BC is congruent to EF and CA is congruent to F. Then we say, if this happens, then we say triangle ABC is congruent to triangle DEF. So, two triangles are said to be congruent when the 6 elements of one triangle are congruent to corresponding 6 elements of next triangle. So, just now we discussed congruency of angles and congruency of line segments, and those two are used here in the definition of congruency of triangles. So, this is how the triangles are congruency triangles are defined, and always the congruent parts are denoted by the ditto mark, single mark and double, triple. Even line segments AB is congruent to DE, BC, EF and AC, DF. So, this is how we define congruency of triangles, and just in the beginning itself we discussed this congruency improves the beauty of the object, and it is used in the constructions of the building, in the construction of the building. When you construct a building, before constructing, we construct the pillars. Pillars of same size and same shape we construct. So, those two pillars, if they are same size and shape, then only the building stands on that, and it gives strength to the building. Till now, we discussed when two objects are congruent, and congruency of line segments, congruency of angles and congruency of triangles. Now let us see similar objects. When two objects are said to be similar. Two objects are said to be similar when they have same shape. This is same as congruency, same shape, and of different size. Size need not be same here. Whereas in the congruent objects, we had same size also, but here we must have same shape, but they need not be of same size, they can be of different size. So, if you look at this petals of the flower, so here one circle, inside one more circle I can draw, and one more circle. So, these 3 circles are of different size, but all the 3 are circles. So, we can say that these circles are similar to each other. And petals also, if I draw the petals like this, they are of same shape. As many as we want, we can draw like this. So, these are of same shape. But when you consider this size, this is small in size, this is little big in size, this is bigger than the previous one. So, petals having the same shape and they have the different size. Therefore, these petals are similar to each other. So, like this we can give many examples for similar objects also. Patterns on tiles you can see, they are similar to each other, and patterns on sarees also similar to each other. Many more examples you can find in the nature, day-to-day life, and plates, dinner sets also you can find similar plates and different sizes, the plates of different sizes and same shape, like that. So, from day-to-day life we can see, in day-to-day life we can see many similar objects. Let us define similar triangles. As in the basic definition we discussed, two shapes must be same. I am taking a triangle ABC and taking one more triangle, bigger one, DEF. Okay, I have two triangles ABC and DEF. ABC is small in size, DEF is big in size. So, these two have the same shape, triangular shape, and one is small in size, the other one is big in size. So, basic definition is satisfied, same shape and different size. Now, here this is a triangle, this is also triangle. If I take a triangle which is like this is a right angle triangle. Even though this is a triangle, this is not having the same shape as ABC. So, even though these two are triangles, we cannot compare them because they are of different shape. And when it comes to a square, something else, square or rectangle, the shape itself, it is 3-dimensional, it is 4-dimensional, right? So, we cannot compare them. So, first thing you have to check that their shapes must be same. So, I have two triangles, ABC and DEF, right? So, ABC triangle and DEF triangle, when these two triangles are said to be similar, the two rules. First rule is the corresponding angles are equal. So it is same like congruency. In congruence also two triangles must have corresponding angles congruent and must have equal angles. So here also corresponding angles must be equal. And second rule, corresponding sides. The corresponding sides in the same ratio. They must be in the same ratio. The angles must be equal and sides must be in the same ratio. If these two rules are satisfied, then we say that the two triangles are similar. Let us see. Angle A is equal to angle D. Angle B is equal to angle E. Angle C is equal to angle F. What are the angles? Corresponding angles. Angle A is equal to angle D. Angle B is equal to angle E. And angle C is equal to angle F. Okay, three angles of first triangle are equal to the corresponding three angles of the next triangle. Then coming to the second point, corresponding sides are in the same ratio or they must be in the proportionality of corresponding sides. Let us write AB is corresponding to DE, right? AB by DE is equal to BC by EF is equal to CA by FD. Okay. So if these two rules are satisfied, then we say triangle ABC is similar to triangle DEF. So this is the symbol of similarity. It is called tilde. This symbol tilde is used for similarity. So triangle ABC is similar to triangle DEF. So here this ratio is equal to a constant. Constant means it is a fixed number K. Based on this constant K, we can guess the size of the shape. Suppose you are given a shape, a triangle or any object. By looking at the value of K, we can tell about the shape, how it is going to be. First rule that we have is, if K is greater than 1, means if the value of K is greater than 1, it will be greater than 1 only when this ratio is an improper fraction. Okay, more than 1 point something like that. Then the similar figure will be enlarged. We get a figure which is enlarged, means bigger one. This concept is used in microscopes. We see the very small objects which cannot be seen with the naked eye can be seen using the microscope. Their object is small and it is enlarged and we can see that object. So in that case, proportionality constant K value will be greater than 1. And second one, K is equal to 1. K is equal to 1 means the ratio is equal to 1. So automatically both the objects will be of same size. It is going to be mirror image. If I stand in front of the mirror, I can see my image as it is. That is nothing but a congruent object. So K is equal to 1, same size. No difference in the size. Equal. And third case, K value is less than 1, we get a diminished figure. That is small in size. Object is bigger in size, but when you see it, it looks very small. The mirrors that we use for the vehicles and all, when it is large distance, it is seen very near. No? In that concept, this diminished figure is appeared. Okay. So this is how, depending on the value of K, we can decide the size of the similar objects. You all know polygon is a simple closed figure consisting of different line segments. When it comes to a triangle, it is a simple closed figure consisting of 3 line segments. When it comes to a quadrilateral, it is a simple closed figure consisting of 4 line segments. When this polygon becomes regular, it becomes a regular polygon when all the angles are equal. If it is a triangle, all the 3 angles are equal and 3 sides are equal. What kind of triangle it becomes? Yes, it is equilateral triangle. And when coming to quadrilateral, all the 4 angles are equal and all the 4 sides are equal. So any polygon, not only triangle or quadrilateral, it can have any number of sides. A polygon is said to be regular when it has all the sides equal and angles equal. So what is to do with this regular polygons with similar triangles or similarity concept? Yes, I'm coming to that point, children. Here, all regular polygons are always similar. If you draw an equilateral triangle, one more equilateral triangle, and one more equilateral triangle, these equilateral triangles, all the equilateral triangles are always similar. Similarly, squares also. Squares are always similar. Not only equilateral triangles and squares, we have one more object. We already discussed that in the congruency. It is circle. One circle, one more circle, and one more circle. So when it comes to similarity, circles of different radii, their radius is different. It can be 2 centimeters. Suppose this is 3 centimeters and this is 4 centimeters. So circles of different radii are similar. So circles are always similar, equilateral triangles are always similar, and squares are always similar. So we can simply say in general regular polygons are always similar. And here these circles are also called concentric. Concentric means circles with the same center, which is useful in solving many problems in similarity of triangles. Children, keep this in mind. Let us see applications of similarity. This similarity concept is used in photography. Photographer, what he will do, he takes a snap of the person. It develops a film. No, it is taken on a film. He develops film to give the print of the photo, right? So these photographs are of different sizes, like stamp size, passport size, and postcard size. Different sizes of photographs are developed from the same film. So there the concept of similarity is used. And in drawing maps also, you might be drawing maps in social studies, India political map, a world map, and Telangana state map. All these maps are drawn using this concept of similarity, which is nothing but the scale factor. Scale factor is used. When you open your atlas, at the bottom of that map, scale factor is seen. To which scale factor that map is drawn. So the concept of similarity is used in drawing maps. And in the mathematics, in mathematics itself, we draw graphs. You learn graphs in polynomials, pair of linear equations and all, no? So we draw the graphs using scale factor or similarity concept. Very big object is drawn on a small piece of paper, taking the appropriate scale factor. And even in drawing blueprints. Blueprints. What is this blueprint? Before we start the construction of the house, we go to an architect to get an idea or how do we want to construct a house. We tell him. He will draw a blueprint. That blueprint also blueprint also we use scale factor. That is similarity concept is used. Kitchen, size of the kitchen is mentioned, bedroom, hall, everything, bathroom, everything that the sizes will be mentioned. After the construction, that small blueprint is converted into a big building, isn't it? After construction, it looks very beautiful, isn't it, children? In the previous classes, when you learn congruency of triangles, you also learn congruency rules or congruency properties in the lower classes. In the same way, here we will learn similarity criterion. We have 3 similarity criterion. First one, AAA similarity. AAA similarity. Second one, SSS similarity. Third one, SAS similarity. Okay, these are 3 criteria. Why do we use this criterion? In the definition of similarity of triangles, we discussed triangles are equal to the corresponding triangles of another triangle and 3 sides must be in the same proportion. So it will be a tedious process for checking all 3 angles and measuring all the 3 lengths of the sides and checking both the rules it takes some time. So to reduce the time, to make it easy, this criterion helps us. So AAA criterion. According to this criterion, we need not check all the 6 elements. Here we can just see 3 angles of first triangle are equal to corresponding three angles of next triangle are not. Just by checking the angles, triangle ABC and DEF, just by checking the angles, angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F, we can say triangle ABC is similar to triangle DEF. Here we need not check the sides. According to AAA criterion, the two triangles are similar to each other. So this is AAA, and from this AAA we can derive AA, angle similarity. AAA means angle, three angles. So only by checking two angles also we can come to conclusion that triangle ABC is similar to triangle DEF. Why? When two angles, angle A and angle D, angle B and angle are equal, angle B and angle E are equal, automatically third angles will also be equal, because by using angle sum property we can find the third angle. No, when these two angles are known, third angle can be calculated. As these two angles are equal to these two angles, automatically angle F will also be equal to angle C. So not even we need not even check AAA three angles. We can check two angles and decide whether the triangles are similar to each other or not. So this is about AAA similarity criterion. Next, coming to SSS, side. So here it depends only on sides. So we have to measure three sides of first triangle and three sides of second triangle. Let us consider PQR and XYZ. Okay. Here, if the ratio of the sides PQ by XY is equal to QR by YZ is equal to RP by ZX. So if the three sides are in the same ratio, we can say that triangles are similar to each other. Triangle PQR is similar to triangle XYZ. Okay, these two triangles are similar according to SSS criteria. Now coming to last one, SAS. According to this third criterion, two triangles are said to be congruent. We can take any type of triangle here. Let me consider here one right angle triangle. Okay, small and one big. Two triangles, two right angle triangles. So these two angles are equal. Let us name it as ABC, and this is DEF again. So here if you observe these two triangles, let us suppose AB by BC is equal to AB corresponding side is D. AB by DE is equal to BC by EF, and angle B is equal to angle E. So here, according to this SAS rule, two triangles are said to be similar when two sides are in proportion and the included angle is equal. Two angles. Included angle. What is the included angle here? Side AB and side BC are forming this angle B. No, that's why it is called included. The angle formed by the two sides is called included angle of the two sides. Similarly, angle E is formed by DE and EF. So this is included. So two sides are in proportion and included angles are equal. Therefore, according to SAS similarity criterion, triangle ABC is similar to triangle DEF. We can use basic definition of similarity also, but there we need to measure three angles and three sides, total 6 measurements we need to collect. But whereas using this criterion, simply by knowing 3 measurements, we can easily decide whether the given two triangles are similar or not. Let us make use of this criterion and solve few problems. Look at this problem, children. Here we have a triangle ABC and triangle AXY. Now let us verify whether these two triangles are similar to each other or not. Let me draw the small triangle like this, AXY, 2 centimeters and 2 centimeters. Okay, now compare the corresponding sides and angles. So here if you see, angle A is common for both. So it is common means using symmetric property, we can say angle A is equal to angle A, right? So angle is equal. Then coming to corresponding sides, AX by AB. What is AX here? 2 centimeters. AB means sum of these two, AX plus XB. So 2 plus 3, which is equal to 5. And the other corresponding sides, AY by AC. If you consider, AY is 2 centimeters and AC is 2 plus 3, 5. Okay. So these two sides are in the same ratio. Yes or no? 2 by 5, 2 by 5. So from this we can say AX by AB is equal to AY by AC. So here two sides are in proportion and this angle is included if you keenly observe. This angle is included. This angle is formed by these two sides AB and AC, therefore it is included. So here also it is formed by, angle A is formed by AX and AY, therefore it is included. So two sides and the included angle means which property? Which criterion? SAS. We can use SAS criterion and say that triangle AXY is similar to triangle ABC according to SAS criterion. So this is how we can check when two triangles are given whether they are similar to each other or not. So by using the criterion we can solve the problem in short. I hope you understood this problem and what all we discussed in this session. So we started with the congruency of objects. In day-to-day life, when do we say two objects are congruent? Two objects are said to be congruent when they have same shape as well as same size. And also two line segments we discussed. Two line segments are said to be congruent when they have same length. And two angles are said to be congruent when they have same measure. Angles of same measure are congruent. And two triangles are congruent when the elements, 6 elements of one triangle are congruent to 6 elements of second triangle, corresponding 6 elements of second triangle. And we also discussed applications of congruency, and then we discussed similarity of objects. Two objects are said to be similar when they have same shape but different in size. And then all the regular polygons are always similar, and we discussed similarity definition, similarity of triangles definition, and then we have seen similarity criterion and also applications of similarity in our day-to-day. One last question, children. Finally, let us compare congruent and similar objects. So here congruent and similarity, one point is common, that is they are of same shape. Both of them must have same shape. Here also same shape, but they are of size also. Here size is also same size, but here size is different size. So using this, now you have to answer one question. Can I say all congruent objects are always similar? Congruent objects are always similar. Congruency means what? Shape and size must be same. Similarity, shape is same but size need not be same. So when we are given two objects which are congruent to each other, then they are always similar because these are congruent, is satisfying both the rules, same size and same shape. So these are automatically similar. But two similar objects need not be always congruent. They are congruent only when k value is 1. We discussed in the definition of similarity. So finally we can conclude that congruent objects are always similar. Similar objects need not be always congruent. Okay. So with this, now it's time for your homework, children. Please note down the homework. It's very simple and interesting. Only thing you have to do is collect 5 objects, 5 examples from your day-to-day life for congruency and draw them, color them. Similarly, collect 5 more objects for similar objects, draw them and color them. Hope you all have enjoyed the class. Thank you.